So let's talk a little bit about a little more detail about the virtualization and container. And I think we got into some of the spot instance information a bit, but in particular, Docker and Kubernetes, and what are they used for, and what are the formats that these things are actually useful for. And so I have, in fact, let me just briefly talk about this. Let's see here. So in terms of Docker format containers, one of the things that I'll bring up is that one of the things to consider with Docker is that there's the Docker desktop, and then there's Docker Hub. And if you are going to be experimenting with a Docker-based workflow, this often can be a good way to do it, is to use the Docker desktop tool, and it will install this Docker ecosystem on your desktop, and then allow you to do containers and have a developer kit, and also even do Kubernetes. And then in terms of Docker Hub, this is a way of checking in your container to a public repo, and then you can actually share your full working application with other people. And also, this concept applies with the cloud native environments as well. So I think that and we'll go through this step by step, but from a high level, the Docker ecosystem is Docker Desktop, this is for local development, and then Docker Hub, and this is for a collaboration workflow. And one of the things that we can talk about real quick here is what's the difference between a Docker container and a virtual machine. And the big difference here is that containers are a lot smaller than a virtual machine, and a virtual machine is really like a simulation of a complete operating system. And virtual machines also can be a lot longer to boot, where a container, you can spawn it in like a second or something like that. And they're also designed to be more programmatically built. So maybe I can just sketch that out real quick and just go through the differences between these things here. So go here and talk about this. So in terms of the different container sizes and differences between compute, we can make like essentially like a comparison here. So for compute, you have the raw metal, and so this is how it used to be for a long time, was that you would have a server, and that server would basically you could do things to it, but in general it was the default place where you would create an application. And a good example of this would be, let's say Solaris was really popular. It's gone away now, but that was a proprietary Unix. And if you bought a Solaris machine for, let's say, $10,000, the only real options you had to use it and to fully saturate all the resources, including the CPU and the memory, and the disk, were that you could maybe do virtual hosting with Apache. So in the old days, and this was, I think, let's say around like 2000, the year 2000, you could actually host multiple websites, and they call this Apache virtual hosting. And all this is it's almost like in a way like the predecessor to some of the things that we're doing now. And you would have several domains that were hosted. So you could have yahoo.com, and then you would have, I don't know, google.com, right? And a lot of companies sprung up that did this, and what happened was they would fork lots of processes in Apache, the web server, and then that's how you would get more resources on a particular machine. But it's crude for many reasons. One of them is it's a physical piece of hardware. And if it goes down, then you're in big trouble, right? And then you have to restore it, and then lots of websites go down. And also a process is a little bit of a crude way to measure things. So then they started to come up with, the next level up here, what we'll just call this compute options. And the next level up was virtual machines. So with virtual machines, what's interesting about virtual machines is that they're able to go through and really make a copy of this. So we can just go here, and what happens is that if you have a very powerful machine, you can literally have an exact copy that's a file that represents the operating system, and so this behaves really similarly to a regular machine, similar to a regular bare metal. But there is some overhead that you get because of the fact that the virtualization engine has to support it. Now, there's a lot of new technology now with virtualization where you can like move things transparently to different hosts. So let's say this is a VM. You could I think even when it's running now, you can move it from one host to another host, right? So there's all these advantages to it. But the virtual machine in general is all it is it's a copy of an operating system that runs as a client on a host, and you can run lots of virtual machines. The disadvantage of this approach, though, is that the spin up time can be several minutes. So it can be minutes to launch in the cloud. And so there's yet a third option, which is the container. And this is really where a lot of people are focusing. The traditional in this virtual machine world, let's just say that was we'll just say from 2000, roughly 2005 to 2020, the virtual machine was a big deal. And in fact, Amazon Web Services, that's been a big part of what they do. They just rent you virtual machines, right? So they're like a Hertz rental car or a Avis rental car, but they're renting you a virtual machine, and they're doing it at scale because they have a ton of capacity and they're just selling you back out. A container is very different in that it's actually more like a process, and it is much more lightweight, right? And so with a container, you can actually spawn them. If you already have something that's able to orchestrate containers like Kubernetes or Docker Swarm or some other container management system, you can launch these things in literally a second, right? Or even I think sub-second, you can launch a container. So they're very good at they're going back to the old days of your virtual hosting on a machine, and you have an Apache web server, and you launch these virtual hosted machines. So it's a lot more like a process than it is like an operating system. And the other thing about containers is that you can create this file, which we'll get into, and we'll create this. You can create like a Docker file, and it's designed to be programmatically created. Where a virtual machine, there are tools that will help you build virtual machines, but it's not really designed to be something that you programmatically create. And so that's the big difference between a bare metal machine, a virtual machine, and a container. So what we can do is go back to this and just see if I missed anything here. So let's see. Some real world examples of containers would be, you have you want to share a project with somebody. So this would be a good one. Like, if, and again, we'll get into this in a second. If I wanted to share with somebody a complete solution, I could give them a virtual machine. I could copy a virtual machine. That's really heavyweight, right? That's a lot of stuff where I just want to give them this one Flask app. This is a great way that you can share it with other people, and you can check in that container into a public repo like Docker Hub. Also a data scientist. So let's say you're doing some research and you're using all kinds of really complex projects, and maybe even you're mixing like R and Python and Fortran, and you're doing all this stuff in there. Well, that could be very complex to explain to somebody. It could be irritating. In fact, like you're on the phone with someone. Okay, here's how you install Fortran, link it into Python. I mean, it could take weeks. So instead, just package it up as a container, give it to them, and say, okay, here's my project. Another one would be, machine learning. Machine learning engineering in particular is heavily using containers. And so a lot of times this is a great way to deploy an application and even include the machine learning model inside of your container. And then some of the things to talk about in terms of running a Docker container is that you get to leverage the power of what somebody else has already built that's an expert. And so here's an example of a Docker-based image workflow here. So in this particular example, you could reference, let's say, Python 3.7.3. And all you need to do in order to use this is go into a Docker file, say from Python 3.7.3, pull it in, build it locally, and then you can check your whatever change it is that you built into either a private container registry or a public registry, and then share that with other people. So you actually get a lot of the advantages of an operating system, but also the advantages of something like GitHub. So that's one of the core features of a container, is that you can operationalize the operating system and the runtime, where you don't really have that ability in a virtual machine. Again, there are some tools that people use, but it's much more complex. And with a container, it's literally a file, right? So you just have a file that says, here's all of the different things that I have in my my runtime. So some of the things also that are common issues that happen with a Docker container is that you do have to handle how to write to the file system. And here's an example of how you could do that. You might need to configure a container for logging. Right, here's another thing that could happen. You also have to figure out things like mapping to an external host. And again, this is an example of how to do that. And also, you may want to tweak things as well. So another thing that you may want to do is actually tweak your container to use a very small amount of CPU, which is pretty nice, because a virtual machine is really not designed to be this granular. Because a container is just a process, you could do something really tiny, right? Just say, hey, I want you to only use a very fraction amount of my machine to do this operation, right? And so we'll get into some of these in a second, but the container registries, this is a good example of how you could actually check in and use a container registry from scratch. And what's nice about these container registries, in this case, this is the AWS container registry, is that you can put private code into the cloud and then also have other applications use that runtime. So I think that's really one of the big takeaways at a container, is that why would you use GitHub? Well, it's because you can have a private and a public version of your source code. You can version it, and you can use it to deploy software. That's the same reason for a container, is you can actually have a private and public version, and you can go through and build it out. So what we'll do is we'll go through here and we'll build out this particular example and create an application here. So what I'm going to do is go next here. So I'll maybe put this in another window and also tweak it a little bit, and we'll make a change. But I'm going to open up Cloud9 again. So we'll keep this AWS focused, and go to console here. To log in. All right, so I'm going to go to the Cloud9 environment, and I'll just build out a new environment here that's maybe has a little bit more power than usual, because I'm going to be compiling stuff and building containers. So I'll just say hello container. Say build a container location, and next I'll go through here and pick which type of instance. So typically, I think for just regular development, it's fine to use a smaller AWS resource. But in this particular example, what I'm going to do is use a slightly larger one. Like in this case, this is an M5 large here. And next, I'll leave everything the same, right? So I'll leave Amazon Linux. Take this. This will take just a second. And I guess what I can do as well is start to build out a container project from scratch here. And probably I can do the same thing I normally do, is create a GitHub repo, and we'll call this container from scratch Python, and just say this is building a container from scratch, and I will initialize a README, add a get ignore here, and then create this README. And then once that's done, I should be able to go back to this environment and just check it out, just so I can store this stuff, so I can share it. So I will go back to this repo and clone it. Go here and say get clone, and there we go. Now notice I don't have the SSH key, so I'll go ahead and create that. SSH keygen -t RSA. Save all this and print this. Here we go. Put this into this location, settings, go to SSH and GPG keys, create a new one, paste this in here, and we'll call this Docker project. Okay. So I've got my code checked out here. I'll CD into it. And so now I can start to build out the scaffolding. So in typically the scaffolding again would start with a Docker file. So I'm going to just copy this code here and put it into this repo. So I'll go here and I'll just touch this file. So in order to build out something from scratch, we can create a Docker file. So it's a little bit like a makefile, right? It's a specific thing that you would include in your project. And then from here, I can paste this in and tweak it a little bit. And you can see that one of the things that I do is I inherit from whatever version of Python that I want to use. In fact, I think there's a newer version of Python, and let me show you how you would find out which version of Python. So if I go to Docker Hub here, and I find Docker Hub, I think I can sign in. Actually, I don't even need, for now, I don't even think I need to sign in. I'll just look for Python, and I can look at the official Python container. And what's great about this public repo here is that experts who are much more knowledgeable than I am about Python, I'm leveraging their work. And if I go here and I say view available tags, you can see all the different versions of Python that I could pick. And so in this particular one, this is 368. If I wanted to look for, let's see, Python 3.8, Here we go, 3.85, Slim Buster, Alpine. Let's maybe pick this one. This was done 11 days ago. So I'm going to put that into my projects. So go to this and say Docker pull. I don't need all that. I just need this part. I just say from that version of Python, and I think I can just leave that out. I can just say basically give me this version of Python 3.85, and then I can also tell it what else I want to build inside of here. And typically, if I was going to build an application, I would make an app directory in my project inside of this container where I would put a source code file, and then I would copy it in, and then I would also install inside of here the software packages that I wanted. So in order to start to do this, I think it's always a good idea to create a virtual environment. So I'm going to go ahead and do that. So I'll say next, I'll say touch, or I'll say Python 3-m virtual environment. And I'll just say container from scratch, CFS, and I'll put a dot here. So this will just put this in my home directory. And from here, I'll say source //.cfs bin activate. Okay, so I've got a Python virtual environment set up. That way I can test things locally. And then I'll also create that requirements file. So I'll say requirements.txt. And then I'll also create a app file here. I'll say touch app.py. And as you know, I like to use a makefile just to orchestrate things, and that's one way to do it. Because we're using a Docker file here, you also could choose to just do it in a makefile. In this case, just so it's very clear, I'll keep things as like the actual commands, and so I could basically simulate exactly what it's doing by doing the same thing locally. So that's all a Docker file is it installs this operating system, and then it runs a series of bash commands in the actual environment that you've set up. In this case, this would be the base environment. So the only other thing I need here is I need to put some kind of an application file inside of here. And so I think I have that here. So I have a kind of a hello world example. And in fact, this looks pretty good. We'll just use this. I'll just create a command line tool and go like that. So here we go. Here's my command line tool. And I can, in fact, as well, just for simplicity's sake, why don't I make a makefile? We'll say makefile, and then I can copy what I typically put in a makefile. So I'll just go to command line tool. I think I have one really recently that I created, which would be Python DevOps course. This is probably a good one. I'll look at an example makefile, and I'll grab the install command here. There we go. That looks good, and I'll put that inside. And always remember that you would change the spaces to tabs. Okay, great. So I got an install command here. That looks pretty good. Inside the requirements file, it's going to be a click command line tool. So I will install pylints, maybe click, and I think that's pretty good. So if I go through here and I run a make install, I can first test this thing locally. I've got all that working. Great. And I can also check this, make this hello world command line tool just test that it works as well. So we can go here and say Python app -- hello or help, and we can see that the help actually works. And if I run hello, there we go, hello world. Now just to make it a little bit more real world, why don't I add an option? And I think all I need to do is, if I remember from memory here, is to say click options and put dash name, I think, and then put in, I think just that, and then put in name, and then I could put in an F string here and say hello world, and in this case I'll just say hello world, hello, and put the person's name in here. So let's just double check that that works. I think that that will work. And also you have to, with linting, with the click framework, I usually will put this thing inside, and this is just tells PyLint to ignore the fact that this is a fancy framework that does all kinds of cool things. Okay, so I've got that there, and if I go here again and I say dash help, click has no, I think it says option. I think it's option. Let's try that. Option. Does that work? Okay, good. So that works. I can put in a name here, and we'll say name, and we'll just call this Bob. There you go. Hello, Bob. Okay, we got that working. So we have some, like, a really simple command line tool working. I have a makefile that has just lets me install packages. So it's pretty much ready to start to integrate this into a Docker environment. And so how would I do this? Well, the way that you build a Docker container is, again, we'll walk through step by step, is you choose the base, you do some kind of a setup instruction here. So in this case, what I'm going to do is I'm going to create a directory in the container. I'm going to copy the app file that I made into the app directory, and then I'm going to go through here and install the actual the packages that it needs, which is in this case just one package. It's click for now. So I'm going to go through and run that, and I believe if my memory serves me correct, I can just copy one of these commands. So I'll say docker build tag app dot. So basically, the AWS Cloud 9 environment already has all this stuff built into it, and all I need to do is run Docker. In fact, let me just show you that real quick before I run this. If I go through here and I go to this environment, although I don't know why this seems like it's maybe I need to do a refresh here. So for some reason my mouse froze, which is not a big deal. I'll just close this, and let me just make sure my mouse still works. Oh yeah, so that works. I don't know, something got weird about Cloud 9. I'll just open it again. Just go to console and go to Cloud 9. Okay, so we want to go to Docker. Where was the Docker? Was it hello container? No, it was DevOps lifecycle. Or was it the next page? It was hello container. That looks good. Hello container. I think that's the one I was just in. Open it. Yeah, that's the one I was in. Okay, so for some reason, it's very weird that the environment just kind of spazzed out here a little bit, which I'm not sure why it's freaking out. Maybe it'll very weird that this particular environment just it won't do a return. Maybe I can open up a new shell. Maybe that'll do it. So here, yeah. So just that for whatever reason, just that shell has got a problem. So I'll just source this virtual environment again and get back to work. So we'll go to the source tilde slash dot bin activate, great, cd into container from scratch. Okay, so as I was saying, if you just run docker help, it's already installed on your machine when you get a Cloud9 environment. And so this is one of the great advantages of using an environment like Cloud9. Has got everything ready for you. And so to run it, really, and I'll just close this other one, all I need to do is run this command, right? This docker app command. So I'm going to go ahead and do that. Go through here, docker build --tag app. And what it does is it literally goes to Docker Hub, grabs the container files, builds it locally, copies the stuff that I told it to copy, and puts it into a container. And what's awesome about this is that later I'll show you, I can check this into another location and have them, work on it. And let's see here. That looks like it's. Oh, let's make sure. Here we go. Okay. Back in. All right. So what I'm going to do is from here look at this command called docker image ls, and it will show me that that application is now built locally, just like this, right? And so what's neat about this is that I can actually now test this out, and whatever I run locally, it'll run the same thing in a remote location. And so what we can do is, again, I'll look back at my notes here, and I can just run this command. And so what this will do is allow me to test out this application. So let's see here, starting docker run it, executable not found in path. Not sure why that's I'm not sure. We'll run it app. There we go. So let's see here. I think what I need to do is just make sure that I have the right command. I think I need to do a slightly different command, which I think is, if I go to docker launch shell Linux, let's see what it is. You would do docker run exec on a container. Let's try this. Yeah, let's try this. Here we go. Yeah, they often will slightly tweak the commands here. So if I go here and I say docker exec and I say app, what happens? Oh, well, maybe that's it. Docker image ls. I certainly see a container called app. Exec, docker exec, at least 2 arguments, bash. Not sure why this thing is having issues here. I might be doing the wrong command here. Let me see if I can find the right container command here. So docker container, if I just want to open up a shell to it, let's see here. Docker container run. Yeah, maybe there is an issue inside this particular environment. Run container in AWS Cloud9. Let's just double check. Let's see what the official docs here say. Okay, we do this, we do this, we do this. Docker compose. So it does look like you can do it in Cloud9 if I remember correctly here. And can't get Docker running on Cloud9 IDE. Let's see. Okay, so there may be an issue. I don't think that's the case. I thought that they had fixed this issue in Docker. But what I can do is we can yeah, I think we can do this. I'll figure this out. So Docker run command locally. Let's just see here what I'm screwing up. I'm pretty sure that command should work. Docker run, assign name, and allocate. Yeah, this should be Ubuntu bash. Let's just try this command. Let's just see if this works. So I'm going to download Ubuntu and see if this works. This is always a good. Okay, so we know it works, right? So I'm obviously doing something. I'm running the command incorrectly here. So they must have changed the syntax since the last time I did this. So I just need to tweak this and say app here. Let's try that. Huh. Executable not found in path. That's very weird. That okay, let's try another one. Okay, maybe this is a good solution. And container test. Ooh, I like it. Let's go through here. Your image, Docker pull, Docker run. Preview the port. Yeah, that does look pretty good here. So in this case, their Docker image would be build it. Yeah, that's interesting. So in just in looking at this particular example here, I must be doing something a little bit weird. Is that this should work, and what's weird about it, and let me just try it one more time, is that we see it, app latest, and if I go through run here, app, let's try latest. Well, long story short is I don't know what's wrong. I don't know what's wrong with this particular image, which we can come back to this. Is that this? Here we go. We'll try one more here. Let's see if we can get this. We can.
You should try this. And you Docker container wrong side.
Yeah, let's try that. Let's see Docker image ls. Maybe that's, I'm just not passing in the ID. Maybe that's like, I like that example you gave me, which is which one was it? It was this. Here we go. Docker run. So if I just want to get into the environment, this might be it. So let's try that. Just Docker run, and I'll just put this image ID. but I want to run bash. That's the issue. To run it in container, interactively. That's what I want. Yeah, that's what we want. This is what we want. Okay. Yeah, I think they might have changed things since the last time that I ran this. Thank you for your help. I think we got this now, which is that if I do this command, I can take this image ID, which is this, and hopefully this incantation works. So we go here, Control E. Huh, that's really weird. No such, oh, you know, I know what the problem is. Is that I think that this is actually in a way you learn more from mistakes than the success, is that I believe that this may not have bash. So that might be, it's literally telling us, I think, what the problem is. So I'm going to change this to, I think stretch was the one that has bash. And so I'll say docker build again. And let me find one. I guess if I want to be lazy, let's just be lazy. And let's use one that I know works. There we go. We know that this one works. And let's just throw this. There we go. And then I'm going to build it again. Yeah, so I think if I understand, I'm pretty sure this is going to work, is that I was using a restricted container that has very tiny amount of stuff installed, and I think it may not even have bash installed. So when I try to tell it to launch bash, it's telling me literally the truth. It's saying, look, there's no bash. I can't run anything. And that's what was tripping me up, which these are the things that are kind of just little gotchas every once in a while that come up and are frustrating, but I'm pretty sure those will work. So if I just say, in fact, if I go back to the command I was using before, I think this should work, which is this. I think this should actually work. Let's see. There we go. Yeah. So that was the problem, is that there are different kinds of, if you notice this, that some of them are really tiny, which are nice because they don't include extra stuff. But now that I've got this, that was the problem. I can go here and I can say Python app like this, and we can see hello none, and I can add my Python app.py and put in a name, and we'll say John. There we go. All right. So that's a very, very subtle little detail there, is that you have to pick the right raw container. Otherwise, if you are going to, let's say, interact with it with bash, for example, and bash is not installed, it won't work. And so that's what the command was that it was telling me, was it was literally telling me, if we look at the failed command, if I would have just read the output, it literally said that. It said, look, you're telling me to use an executable that doesn't exist. And so it was actually telling me what the truth was. Okay, so great, we got that working, which is pretty awesome. So which is kind of neat, but let's make this a little bit more tricky here, and let me show you what we can do with this now. So I'm going to add all this stuff in. I'm going to commit this, adding files, go. It's going to, I think, complain about all that stuff. I'll just change this, put in my name. There we go. And then I will change the email address here, like this. And then I'll change the last part and then push this in. And then I'll give you access to this repo. There we go. Out and exit. Okay, push this. So this git push. So this repo is right here. So it's this one, which is called Docker something. Docker. I need to go to my repo and find my repo. Container from scratch. Okay, so I'm going to take this, throw this into our chat. Okay, so we got a full working kind of hello world. But let me just sketch out what I'm going to do next here, because it's somewhat useful, but it's not as useful as it could be. And let me show you what we're going to do next. So the next thing that we're going to do is that I'm going to push this image to other locations, and I intentionally made it simple so that we can explore the concept. So Docker, in a kind of a hello world setup here, the first thing you do is you maybe get a cloud environment to write code in. So here we go. Here's our cloud environment. You then go and pull a base image from Docker Hub. So in this case, this is Docker Hub, and you pull a base image inside of here, and this base image, would include something like the experts, the true experts who are. And let me just even show you how good these things are inside of Docker Hub. So if I look at the one that I just included, I'm just going to find the actual name of it like this. I'm gonna literally look at the source code because you can see it inside of here. So if I just type this in, here we go, stretch. It will literally tell you each of the commands that they're putting inside of here. Although they also changed this recently, which is kind of irritating, is if I want to look at the actual file here, I don't know what they did here. They made it a worse interface. But basically, you can see there's a bunch of commands that I don't want to manage. That it really is irritating. That I don't want to manage all this stuff. It's really complicated stuff that the experts that build Python every day, I can just take all of their expertise and their smarts and put it into my project. So that's what this does is I get the expert stuff inside of my Docker file, and this is their base. And you can see you can even restrict it so much that even Bash doesn't come inside. So you have a lot of options about how to do that. So that's the base part. Now that's somewhat useful to build this out, but unless you put it somewhere, it's not going to be that powerful. So what I'm going to do next is I'm going to stay in the AWS cloud here. This is AWS cloud. And I'm going to create a container registry. And what a container registry is, like a private version of Docker Hub. And this private version, private container registry, this would be for you to share things with other people in your company, right? So you could have like proprietary source code, computer vision applications, or all kinds of stuff that you don't want other people to have access to. But you can build these out and build these solutions out to other people. And then I'm going to push that there. And then I'm going to set up another cloud environment, another Cloud9 environment, and I'm just going to run my application. So you could be building these Docker containers for other people in your company, push them into a container registry, somebody else uses it. So they don't even need to understand anything that you did. you could be building these command line tools or Flask applications. So that's the next thing that we'll do is we'll push this and I'll pull it into a new environment. So let's go ahead and do that. Next is I'm going to go to the this environment and I'm going to find the container registry. So they call it ECR, Elastic Container Registry. And what I will do is create a new repo. In this case, we'll call this Docker CLI. And I will, now notice this, actually, you can even do like scan images as well to do, I think this is a security feature they just added, but I'm going to go ahead and say, yes, I'll go ahead and create that. Now to push it, what I'm going to do is I'm going to click on this and then I'm going to say view push commands. When I say view push commands, it gives me step by step the commands that I need to do in order to authenticate and push this into my registry. So I'm going to go ahead and do that first. I'm going to copy that and go back to my container environment and put that in. So I'm going to say, there we go, ECR get login password. Great. Now it stores it encrypted in, it's stored unencrypted in this location. So you don't want to give that to other people. And then the next thing I'll do is I'll build it and I'll tag it with the name of my registry so I can associate with it. So we'll go ahead and copy that and I'll paste that in. So it's going to build a new version of it that I'm going to push into this location. There we go. We see it builds it again. Okay, next what I will do is do a push or tag it and then push it. So we'll tag it. So we'll create some unique identifiers to that particular build of the image, because you could build lots of different versions of this same project, and then I'll run the last push command, which is this. And on all this push command is it's telling you the path to where their container registry is. So we copy this, make sure double check I copy that, go through and push it. There we go. Now, keep in mind as well that because these are all in the same cloud, the speed is going to be very fast in pushing this back and forth to other locations. So if this was on a Wi-Fi network or something and you're pushing it, it could be very painful. Okay, we got that running. So in order to test it though, I'm going to need a completely new environment. So fortunately, that's pretty easy with AWS. So I'm going to open up yet another cloud-based environment from scratch. And it could be anything too, by the way. It could be a virtual machine. It could be Cloud9. I'm going to go to Cloud9 here and run this. And I will say create a new environment. And we'll just call this, run Docker image. And this is for testing my Docker images I pull from Amazon Elastic Container Registry. There we go. I can go through and it doesn't need to be anything fancy because it's just going to consume the thing that I built. And it's pretty straightforward to pull this into another project. It also could be deployed in Kubernetes as well. So if I wanted to deploy, if I had something bigger, like a large application, I could also deploy it in their managed Kubernetes service. But for now, let's just test out the simple workflow, which is this, just pulling it from the container registry. Well, that's okay. Well, it's connected. So, all right. All I need to do, let's just notice a few things here. This is a blank machine. This is brand new. There's nothing on it. In fact, ls, there's nothing, right? So all I need to do is just pull from that other repo. So what I'm going to do though, is I'm going to run the history command, and I'm going to first use their login command. So I'm going to just run this. So I'm going to do this, and I'm going to use that login command for this other container so that I can first auth to it. There we go. I auth to it. Should take just a second. There we go. And then once I do that, all I need to do is say docker pull, and then I just need to put in the path to where that lives. So I just need to pull this here. I need to pull that. There we go. And I say docker pull the docker CLI. And let's see, docker pull. Actually, I think it even tells me the command. Hold on one second. Maybe it's just this. Let's just say docker pull that. There we go. Oh no, that's my own. That's my own. That's the wrong machine. This is the new one. I just need to do this. I just need to say docker pull, and pull it here. Say docker pull, there we go. So it's docker pull, and then the actual repo URI. This should take just a second. Okay, great. Now that I've got that running, to use it, I can say docker image ls, and I should see inside of here that we've got that CLI here. And so I can basically just mimic what I did before. So which is, I think I had the command here, which is this is, where is this docker command? Yeah, basically this docker run here. So go to this docker run, but I say, and by the way, that's the wrong environment anyway. I would say docker run. Let's just make this bigger. And it would be this. I think it's, let's actually see if the short name works. I don't think it will work, but let's see. Okay, so I think you have to put the full name here. Although I think you can say the image ID too. Let's just do the image ID. Let's just do that because I think that might be docker run. And let's just put the image ID, which is shorter. I think you can put either one, either image ID or the full name there. There we go. So now we're in the application, and you can see it's instant. Like it literally sub-second. If I do an ls, I've got my application, and I say -- name, and we'll say John again. There we go. Hello, John. Hello, Bob. Right. So intentionally a simple application here, just to show that the fact that you can package up something, and this could be a very, very complicated application. In this case, it's just a simple hello world application. Now, let's make it even more interesting, and let's also make this available to the general public. And so what I'm going to do is I'm going to go to Docker Hub and log in. Hopefully, I still have my password. If not, I could create a new account or something. But let's go here. I'll sign in, and that looks like it works. and I'm going to create a new repo, and I'm going to call this cloud app, and just say this is a hello world cloud CLI tool, and I'll make it public. There we go. And then I even can say automatically trigger every single time I do a build, and it will automatically even check this into my repo for me. And so let's try this out. I actually haven't tried this out, but I'm pretty sure that this will work. And this is a container from scratch. Let's try that out. Let's view the build. That looks good. Okay, create and build. Let's see if this works. And I believe if I go to builds here, that auto test build trigger, you could trigger your automated build by sending a post request test. I don't know how this works, but I mean, I guess I can just tell it to build it by just clicking the README file and just say, build this. So you can either push it yourself, or you can be lazy and just, I think this will trigger the build. I have never tried this before. I'm just guessing. I know how it works. Let's go back to builds here. I don't know why this is not automatically building. If it's not, I'll just do it manually. I don't see recent builds. Click here to set up builds. So maybe I didn't fully build this. Oh, use my, there we go, container from scratch. Yeah, it should be working here. I'm not sure why that's not working. Let me close this and put this back over here. Use my own, oh, this says trigger new build. Yeah, well, we don't have to do automated builds. I don't know why it's not working, but all I need to do is push this in here. So that's what I'm going to do next here is I'm going to say Docker image. I'm going to go back to this other container and try to do a push. So I'm here, and I try to push this, and we'll call this we'll call this Cloud9 or something like this, because this is coming from Cloud9. And this push refers to a repository Docker IO. This image doesn't work, so I need to first authenticate to this. And I think I have some instructions on how to do this here. So it would be this. So I would first, I could make like a little script here that does this. I think this is the way I did it before. And so I can go back to my hello container environment and just touch, we'll call this build.sh, and I will go here, and let's see here. So the tag looks like this. It assumes you're going to do that. That looks good. So we'll go through and build this up. And so it's going to say Docker path would be I don't think so. We're going to call this Docker path cloud app. Let's try that. Ooh. Cloud app. So this should authenticate and log in and then push. Let's see if this works. So I can say chmod plus x build, and let's see if that works. Log in. Hopefully I know what my password is. Okay. So basically you have to first authenticate to this environment, it then builds it with a custom tag that I had. And then if I go back to this Docker Hub, if I refresh this, there we go. We see that there's actually something in here. So how would I test this out? Is, by the way, you can pull this, so you can try this yourself right here. And I can put this even in the README here and say, if run it yourself, I can do this, bash, like that. And then you would say the command would be similar to whatever I did here. It would be like this. It would be something like this. It would be docker run, and then it would be that. It would be this would be the command, I believe. There we go. Let's see if that works. So I'll go ahead and commit that change. So now I'm going to run that locally and see if I can get this version of it running. So Docker run, go to Docker Hub, pull this down. It pulls down the new image, which I also happen to have locally as well. But this is it treats it as a new image. I go through here and I say name, and we'll call this Sally. There we go. So let's sketch out the workflow here. Is that in addition to the fact that I was able to push this Docker container and get it working in the private repo, I was also able to get it working and get it into Docker Hub. So after I built that, then I went to Docker Hub, and from Docker Hub, I was also able to push it, and then another environment could run it. So in fact, anybody in the world, so this is public, like anybody now can run my container because I pushed it into Docker Hub. So you really have these two options. You have build it into a private repo or build it into a public repo. So why would you do one or the other? I mean, one of the big ones is security, right? If you have proprietary code, you don't want to be pushing it into the public repo. The other one though is also the runtime. So if we go back to Kubernetes here, like Amazon EKS, we don't have time to get too much into the weeds on this for right now, but we can get into it in a little bit in another session. But basically, what you can do here is that you can provision a Kubernetes cluster and then deploy worker nodes. So if these were, let's say, web apps, we could put it into the Elastic Kubernetes cluster, and then we would have a bunch of web apps running. Or maybe it's background workers. Like maybe the workers are doing, like, they're pulling websites, or they're building machine learning applications, or whatever it is that they're doing. But in nutshell, this Kubernetes system, it would fit in very nicely with what we did. And so to kind of get ourselves there piece by piece, the next thing that we can do is actually go beyond just a simple command line tool, and let's build something slightly more complex, and let's build a complete machine learning application, and then test that out, and then show how that would work. So what I'm going to do next here is I'm going to go back to my hello container, and I'm going to basically start over. I'm going to make a new project on this thing. So I'm going to go back to this. I'm going to deactivate this virtual environment, and I'm going to go close all this stuff up, and I'm going to make a new project inside of here. And I have already basically everything I need, and that might be the best way to do this. Is I have another project called Container Revolution, and Container Revolution, and I should probably whiteboard that out as well, what this actually does. So this particular application, let's just whiteboard out what this container actually does. So the command line tools are actually pretty useful because you could deploy these tools to data scientists or data engineers or build workers or background jobs. Or I mean, there's lots of reasons why you would want to build something like we just built. But even more interesting is, what about a containerized machine learning application? ML application. So in a containerized ML application, what are the pieces that we would need, especially in Python? So we can think about the scaffold again here, and the pieces generally would be that you again would have, I think a make file is something I do a lot, orchestrate things. We need a Docker file. You also would need a machine learning model. And so typically the way you would grab one from scikit-learn is, with scikit-learn, they have something called joblib. And joblib is a serialized model that was trained with, let's say, scikit-learn. So I later, or maybe I use Colab Notebook, or I use AWS Machine Learning, SageMaker or something, and then I save it out to my project. And then I would build a Flask app. And so I could just have some app code. And then potentially I would also have some helper code, like, for example, like a prediction script, like a bash script that made like a prediction script. And that's pretty much what you would need to build out a containerized application. And then what you would do is you would build it and test it locally. And again, like Cloud9. And then we would do the same process that we just did, which is we would take it, we would push it to ECR, or we could push it to Docker Hub. We could push it wherever we want. And then you can actually run that somewhere else. So this is actually really useful in that it's basically all ready to go for someone to build a giant distributed prediction system using potentially, you could use EKS right on AWS. You could use the Elastic Kubernetes service and deploy like a swarm of these things, and each of them could be load balanced. You could also deploy them to other clouds, like they have Google Kubernetes or Azure Kubernetes. And what's nice is there's nothing specific about this machine learning application. It's got everything it needs and it can run anywhere. So let's kind of test this out and get this working locally here. So the next thing that I'm going to do is check out that project inside of this environment. So I'm going to go to this code here and just do a git clone. So I will copy this and do git clone. There we go. So git clone. And then I will cd into here. And from here, it pretty much has everything I need. So I'm just going to create a Python 3-m virtual environment, and we'll call this .cr virtual environment. And then I'll source it. And from here, I'm able to basically cd into, or I'm already cding into it, is just run a make install. But I'm going to go into this demos directory because it's in here. And then I'm going to say make install. And we can see exactly everything that's happening in this project. If I go to let me I think that this, oh, that's so funny. No, I couldn't install the project because there's no space left on disk. Well, that's one of the downsides of this, is that I have put a bunch of containers here. And so I think I can say, I think you can, to delete a specific container, we can say Docker container delete. How to remove Docker images. Let's see, I always have to Google this. I think I can just say Docker system prune. Let's try that out and see if I can just nuke some of these all networks. Sure. Let's delete a bunch of containers. Hopefully this doesn't blow up Cloud9, which it might, because I know Cloud9 might use some of these containers, but there we go. So I that looks like I should be good to go. And then also I'm gonna move this project into the environment so it shows up in this shell here, because I don't see this little tree view is kind of irritating in that it doesn't show up. It doesn't show up unless you put it into an environment. So I'm going to move this container revolution code into environment. There we go. So then it shows up in this little wizard. Okay, so I got this here. I will again cd into it. Environment, container revolution, demos, Flask. Okay, if I do make install again, this should work. Okay, so got this thing working. Now let's just look at all the different code inside of here. So the first thing is this Flask application is basically a really, again, kind of a really simple Flask application. And I build a scale function here. And what this does is it takes a JSON payload and scales it so that we'll get good predictions. Like essentially almost every machine learning model needs the data to be in numerical format and needs to be scaled, right? So I have to scale this data. The next thing that I do is I have like a hello world route here just so I can test my application. It's often like a good way to kind of test things out is to have a hello world. And then I have my actual prediction. And so what this prediction does is it allows me to do a post operation. So I told this route in Flask to only accept post values that appear at /predict. And then from here, we will accept this JSON payload and I'll say, convert the JSON payload into a pandas data frame, scale the data, and then return back a prediction. Now, notice this is loading the model off of disk in something called Boston Housing Prediction.joblib. And you can see it's right here. And all it is a serialized out machine learning model. So it was trained somewhere else. I saved it, and the model has got all the smarts in it, and I load it into my Flask application. So what I can do here as well is, you notice this is on port 80. I'm going to change this to, like, let's say port 5000, which is kind of typical when you're running it locally, is to run it on a non-privileged port, so I don't have to type in sudo. And that looks pretty good. So I'll go ahead and save that. And then I can just run this locally to just test it out. So I'm going to say Python app, and does it work? Hopefully it does. It looks like it's working. Now, how do I actually test this thing out and play with it in Cloud9? So there are a couple ways that you can do this. One is that I could just curl this. So if I open up a new terminal, I could just curl localhost here like this and say curl localhost. There we go. And we see that this thing's working, right? Because that's the main route. If I want to run the prediction, I can go here and look. We can change this port to 5000, right? Because that's the port that it's running on. And I also can verify that, okay, yeah, that's localhost. So it looks like that should work. And all it does is it sends in a JSON payload that makes it do a prediction. So same thing. Let's go ahead and do this. We'll say make prediction. Maybe I have to say, I have to cd into there. So I have to cd into this. Hopefully you can drag it in there. Nope, it's not that sophisticated yet. Demos, Flask, and then I can say make prediction. There you go. So it's working. And look, if I look at the output here, we can see that it's logs out that it's doing predictions. So we got a working machine learning application doing predictions. Great. So the other one that I would do next would be that I would now make sure that I can run this thing from a container. So how would I do that? Well, we can do the same techniques that we did before. So if we look at this Docker file, we can see that it's pretty close to the other command line tool here. Same thing. We use a big version of Python. Although I wonder if I could make that smaller. I'm actually curious about that. I could experiment with it. We could see which port. Just for simplicity's sake, I'll tell it to export port 5000, and then it's very similar to a command line tool, right? Very similar to a command line tool, and this just runs in the foreground. So I think that it might be possible to use a smaller version that would take less space, but I'm just going to keep it simple for now and not mess with that. But that might be something to look at in the future. So how would I run this? I would do the same thing I did before. I would say run Docker. So Docker build this image, list the image, and then now we can even test it locally. So I can just say here 5,000. So what this tells your machine is what port do you want it to be exposed to the outside world, and then what port is the container itself running on. They don't have to be the same thing. Just for simplicity, I'm making them the same thing. And so I can run this command. It'll build the image, list it out, and then it'll run it. So I'm going to do it just by hand, though, just to start with, to make it easier. So first I'll build it. Hopefully I don't run out of space, which could be a problem, but hopefully I don't. Okay, looks like that's working. Download it, build it. Okay. There we go. Looks like it's building the image successfully. Everything's working. Now notice also a couple things that I'll point out. And one of them is that this requirements file here, notice that it's pinned. And this is critical because the library itself has to have a repeatable version. And so I know that this version worked, even though Flask and Pandas and scikit-learn in the future have changed a bunch. These are the specific ones that I know for sure will work. There we go. So we got it working. And if I look at it, I do a df command, we can see that I think I have actually some gigs available. So things aren't too bad. So I've been able to build it. Next up, I'm going to do a image ls to just see what it created. And we see here, look, Flask scikit-learn, great. So I've got that thing working. That's great. And then I can now run it. So I can just type this command in, and then this will go through and run it. There we go. And now it's running on port 5000. So now this is running in my Docker container, not running locally. And if I go back to my prediction application here, I can, I think, just say make prediction. Yeah, and there we go. And it works. And you can see now it's showing the output in this Docker container. So this is definitely more of a compelling case for why you would want to use a container. And what we can do next here is, and obviously if I stop it, the Docker container, right, this won't work anymore, right? Doesn't work, failed to connect. So now let's take this and let's do the same thing we did before, which is let's check this into the container registry service and then run it from another machine. So I think I can just do the same thing, create another repo, for example, and we'll just call this Flask ML. And I can create this repo, and we'll do the same exact series of commands. So I can click on it, look at the push commands, and I think I'm already authenticated, so I don't need to do this, but I can do it again just to be safe. Okay, I'm authenticated. I can build the image again here, and so I'll go through here, build it. Hopefully, again, it don't run out of room. Okay, it looks like it's good. I can tag it. There we go. And then I can do the last step, which is push it, which should be pretty quick. There you go, push it. So this is pushing this to my container service. There we go. Okay, looks like we're able to get this thing cooking here. All right, so we got this. We got this thing cooking. So what I'm going to do now is I'm going to go back to my other Docker image. You're right. The one that the other. This was just for running things, and I think I'm going to. So obviously there's no tricks here, and there's nothing on this machine at all, other than these images. I think I will need to run that prune command though, just to be safe, which is we'll just get rid of anything that's unused. So I'll just run this Docker system prune that will just get rid of like old containers that I was using before. And then next up, I'm going to now pull that image, right? So I'll do the same thing I did before, which is I'll say, I could pretty much even look at this and copy. All I need to do is say Docker pull space, go to the ECR location, and I think it's just that right there. And I can go to that. There you go. So pull that Flask image locally. There you go. I pull this locally. And then what's really awesome about this is that there's a bunch of really sophisticated code that's built inside of this that I can run locally, and I don't even need to know what even the word machine learning is. I can take the code, just say Docker run, and it's now running in this other environment. So that's basically the core concept behind containers. So let's go ahead and test that out next. Okay, that looks like it's good. Got this thing running. Okay, so to do the prediction, I can go to this other machine here and just kind of copy the commands that I had here. And so it was, I think, just something like this, and we'll just tweak it a little bit. So we'll say Docker image. So it'd be Docker run, and then I think it's going to be this. This is the name here. It could be this, I think, or it would be the image ID. So let's go ahead and run that. Does that work? There we go. Now we're running locally. So I personally think this is kind of magical that you're able to take that much intelligence and just shove it right into a machine. Now, to do the prediction, I could also, I have to do a little bit more work because I have to know how to call the API, but I could for sure I could do curl localhost 5000, and that'll give the prediction home. But if I want to serve out the actual prediction, what I would do is just make a file real quick and just call this like predict or something like that. And then I could go back to this other machine and just grab it just go here and just copy what's inside of here. Just because it's kind of a big command, I don't want to type all that out and just put in all the different options here. Say, okay, port 5000, that looks good, okay, great. And so I can just say bash predict. There we go. And now we know that this thing works. So really that's the only thing someone would have to do to test this out and run this locally. So you could deliver a complete working solution to somebody else. So let's just kind of summarize, because that's pretty much gets us to where I wanted to get to for the containers. Let's just summarize the whole process and just whiteboard out every single thing that we did, and then the next steps that we could go through next time. So let's just make sure this is working. So the core idea is that you have metal, you have a VM, and you have a container, and a container is the smallest one, right? And each one is a subset of the other. So you can have many VMs on a physical piece of hardware, and likewise, you can have many containers inside of a VM. And a container, the advantage of it is that you can package up programmatically your code. So programmatically, right? That's the key takeaway. And in addition, you can actually distribute both the runtime and you can distribute the actual source code, and you can do it in two ways. You can do it in a public manner right here, or you can also do it in a private cloud environment, and depending on what cloud provider you're using. In this case, we decided to use AWS. You could have ECR, the Elastic Container Registry, be the location where you store all this stuff. And then you also could hook that into its container services. And they have the ECS, which is the Elastic Container Service, and they have EKS slash Fargate. And those allow you to run Kubernetes. And all this does is a fancy way of saying we were doing stuff individually that was served out a machine learning application, but you could create a cluster, and we'll get into this in a second with Kubernetes. You could create or in a later session, we'll get into this. You could create a Kubernetes cluster here, and you could have many of these, right? So you could have, instance, 1 here, you could have instance 2, you could have instance 3, and then maybe they're even all coming through some route called, myapp.com, and then they're all, hosting this cluster of machine learning predictions. So that's really the main takeaway, is that you can check in the runtime as well as your source code, and even package in things like a container, and then put those out into an environment. And it works the same. The concept is identical with the Azure Kubernetes service or Google, their Google Kubernetes engine, is that you basically have what we just built, and you check it into a repo. So that's probably a good place to probably stop.